Today we'll be teaching on misleading graphs and how to identify them. So we'll view 5 examples and how maybe you could fix them so you know that they're misleading graphs. So we're looking at page 100, 2.3, the 5 examples on misleading graphs. And the first one is misrepresentation of data. So the first figure, if you could look at it, it's the burglaries in the U.S. 2009. And you could tell by it's misleading because if you look at the 2 points that they have vertically, it's other months and then July to August. So when you're doing your points like this, it has to be equally spread out. So it looks like through this figure 19, it looks like the burglaries in July to August is way more than the other months. But if you do the burglaries for each month, on figure 20, you could see that they're almost the same. Like all the months have their own bar, and it's more likely that it's the same. Whereas if you compare 19, it looks like in July to August, the burglaries maybe doubled its size. So example 2 is misrepresentation of data by manipulating the vertical scale. So figure 21, it's opinion regarding this case. If you look at it, it looks like the Democrats are resulting way more than the Republicans and the Independents. But if you look at the percentages on the sides, it's only by 1. Whereas if you look at figure 2, it starts at 0, and it looks way more equal because if you look at the bar graph for 21, it just looks like the Democrats are just not even, its bar is like doubling, so it could even mislead it. Whereas if you start from 0 and you have maybe by 10s, it looks practically the same. The opinion regarding this case is practically the same. Whereas this one, it looks like the Democrats are outnumbering everyone. So the third example is misrepresentation of data by manipulating the vertical scale. For figure 23, it's the average SAT math scores over time. And it looks like through 2001 to maybe 2005, it's exceeded way more than 1991, whereas where they started. But if you look at figure 24, it tells you that it's mostly the same. It hasn't really excelled, or it's only a little change. But what you could do is you could do points as figure 25 to have a better representation of the scores that year. In example 4, it's misrepresentation of data. So for figure 26, they're using graphics, and they're using the little toilet rolls and stuff. The problem with this is you're not sure if the roll is included with it. So if you take the rolls away, you only see the little paper, and that's it. But it doesn't really say if you include the paper roll or not. So 41% uses their shoe, 30% act normally, and 70% is paper towel. So what you can do is you need to see if the shoe, since it's 41%, is it 2 times more than the paper towel? Does it look like it? And so because you're not really sure if the graphic is included with it, it's very misleading. Because if you include it, it doesn't even look like 17% is half of 41%. Do you see that? Example 5 is another misleading graph where they still use graphics, and it's talking about soccer participation, and it looks like 2007 has had maybe 300-400% increase of 1991. But if you look at figure 28, it gives a better representation of the participation. So it gives the same graphic, the same size, instead of making it look like 2007 had a humongous population of it. So there was a 1 million participant. Each graphic was 1 million participants, so it looks better and it doesn't look like 2007 had so much that it overwhelmed 1991, whereas it's this small little circle compared to 2007. Oh, there's example 6. Last example on misleading graphs. These are 3D graphics. This one on figure 29 is active duty personnel. And it could look misleading because since it's 3D, you're not really sure where it stops. So the best way to fix it is figure 30, where it's only two-dimensional. And so you know exactly where it ends. And those are the 6 examples of misleading graphs.